simplifying monomials. All right, so here's the four basic rules when we do this. To simplify a monomial expression, write an equivalent expression in which 1. Each variable appears only once. 2. There are no powers of powers. 3. All the fractions are in simplest form. That's always the case. And they're only positive exponents. So we won't see any negative exponents for now, but don't worry, they'll show up eventually. So we've got our 4 rules here. Each variable only appears only once. No powers of powers. Fractions are in simplest form, and no negative exponents. All right, let's get complicated. All right, we're going to simplify each of these expressions. I've got 5, a squared b cubed c to the 4th, and I'm going to multiply that times 6, a cubed b to the 4th, c to the 2nd, and all of that last monomial is squared. So I'm going to work one thing at a time. What you're going to find here as we work with simplifying these monomial expressions is that you can kind of come at it from a lot of different ways. It's up to you as long as it makes sense and it's kind of a legal move, totally fine. How much you show of your work, I would really like you to show a little bit as you go so that don't try to keep it all in your head and slam one final answer down on the paper without showing anything in the middle, because then we can't help you if it turns into a mess. So show some of your pieces as you go along, kind of show one thing at a time, and please only do one thing at a time. So here for this one, I'm going to start with this second monomial, and I have a power of a power here, so I'm going to deal with that first. So my 6 squared is 36, a cubed squared is a to the 6th, b to the 4th to the 2nd power is b to the 8th, and c to the 2nd to the 2nd power is c to the 4th. Okay, now since both of these now are just 2 monomials, I can put bases together that belong together. So the 5 and the 36, they are not like bases, but they're old school coefficients. I'm just going to multiply them. I get 180. My a squared times a to the 6th. So this is like a times a, times a times a times a times a times a. There's 8 of them, so I end up with a to the 8th power. B cubed times b to the 8th, b to the 11th, c to the 4th times c to the 4th, c to the 8th. So here is my final simplified expression. Again, each base only appears once. All fractions are simplified. There's no fractions. That's easy enough. No powers of powers, and we don't have any negative exponents. So bam, good, and we're done. All right, let's see what other kind of a mess we can create here from our monomials. All right, I've got 2g h to the 4th to the 3rd power, negative 2g to the 4th h to the 3rd. So both of these are powers of powers. So I'm going to deal with one at a time here. And again, this is what I mean by don't try to do it all in your head. Please write down partial pieces as you go. So I'm going to take this first monomial, and I'm going to apply that 3rd power there. So I get 8 g to the 3rd, h to the 12th. I'm going to take this second monomial and apply this cubed to it. And a negative times a negative times a negative gives me a negative. So I have a negative 8 here, g to the 12th. Don't forget that this h, just like the g here, has an h to the 1st power. So 3 times 1 gives me h to the 3rd. From here, then, I can, again, continue to put those like bases together. 8 and negative 8. That's not, we're going to write that out as negative 64. When we're writing a monomial, if we have kind of a coefficient at the front, we're going to write that out as the number. Don't leave it as a power. Write it out as a number. I mean, unless it's a ridiculously long one, but for the most part, write it out as whatever number it is. So I have negative 64. G to the 3rd, g to the 12th gives me g to the 15th. H to the 12th, h to the 3rd gives me h to the 15th. So here's my final one. Again, each base appears only once. I don't have any powers of powers. All fractions are simplified, and no negative exponents. Check, 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 check. All right, last one we're going to work on for this particular set. I've got negative 3d squared f cubed g to the 2nd power. Then I have negative 3d squared f to the 3rd power, and that's all to the 2nd power. So since I have power of a power of a power here, I'm going to work on this second monomial first. So I have, let's see, I'm just going to work with these outside ones. I'm going to go from the outside in. You could go the other way, that's totally fine, and give this to the 6th power. My first monomial here, negative 3 times negative 3, since that's squared, gives me a positive, so I have positive 9. D to the 4th, f to the 6th, g to the 2nd. I still need to work with this second monomial because I have to apply the 6th power here. So this first one doesn't stay the same, I just bring it along for the ride. A negative to the 6th power will give me a positive coefficient here, so that's 3 to the 6th. I'll deal with that 3 to the 6th later. D to the 12th, f to the 6th. And now, since I don't have any more powers of powers, I can multiply these bases together. So 9 times 3 to the 6th, ugh, that's ugly. It gives me 6,561 is my coefficient. d to the 4th, d to the 12th, d to the 16th, f to the 6th, f to the 6th gives me f to the 12th, and then I only have one base of g, so that stays as my g to the 2nd. So again, double checking. Each base appears only once. I do not have any powers of powers. All fractions are simplified, no fractions, and no negative exponents. So again, as you work through these, one piece at a time. Do you have to write everything that you do? No, but I would highly suggest that you write down one piece as you go, following those basic rules that we talked about working with our monomials.